Okay, hello everyone. We're gonna go ahead and talk about graphing linear equations. There's a couple of topics that I want to go ahead and cover today, which include like the basics, coordinates, and scatter plots, graphing linear equations, um, the slope of a line, quick graphs using slope-intercept form, writing linear equations in slope-intercept form, as well as another section 5.3, which I can't remember the name of. But this should be like an all-encompassing video, I hope. I'm gonna try to make this as short as possible. Definitely not gonna put timestamps, but I'll try to be quick slash also summarizing the work, or rather the topics a little bit better, just so you don't have to sit through like a whole 30-minute video, which I hope I don't get to. Anyways, coordinates and scatter plots. The coordinate plane is formed by two real number lines that intersect at a right angle. Each point in the plane corresponds to an ordered pair of real numbers. The first number of rather in an ordered pair is the x coordinate, and the second number is the y coordinate. We usually write this. This should be pair. The ordered pair is usually written as the x value first, followed by the y value, right? X coordinate, then y coordinate. Something similar to this that I've discussed with my class. If you weren't part of my class, then you probably didn't hear this, but this is almost similar to a video game called Minecraft. But in Minecraft, we have three planes, three axes, right? We have the x-axis, the y-axis, and the z-axis, right? It's a little bit different, but in this case, what we're going to be learning about today is just like the 2D plane, right? So just talking about x and y. So how we look at this and how a coordinate plane usually looks like our image below. We have a vertical or the y-axis, right? Vertical axis. We usually call this the y-axis, and then finally the horizontal axis or the x-axis. This is from you going left to right, and that's how we'll always have it. The y-axis will always be vertical, and then the x-axis will always be horizontal. Another side note as well is that right smack dab in the middle is what we call the origin. The origin will always be 0, 0, basically your starting point, right? The center of all things in the coordinate plane. So, the x-axis and the y-axis, the axes divide the coordinate plane into four quadrants. You can tell which quadrant a point is in by looking at the signs of its coordinates. You have the quadrant 1, 2, 3, and 4. In quadrant 1, you'll always have positive x and y values. In quadrant 2, you'll have negative x values with positive y values. In quadrant 3, it's all negative. And then finally in quadrant 4, it'll be positive and then negative x values, then y values. In this case, anything that's always, or rather that's on the line, like what we have here at the way bottom, 0, comma, -4. This point, any point that's within the lines, any of the axes, will not be categorized in any of the quadrants, right? This is mainly because we can't really determine the sign of 0, and because we can't determine what the sign of 0 is, then we can't really put it in that kind of category, right? It has to be either positive, negative, right? So on and so forth. But since 0 doesn't really have a sign, we can't really put it in anywhere. So whenever we are drawing, right, anytime we're plotting the points in the coordinate plane, we always want to first focus on looking at the x value of the point first, the ordered pair, and then followed by the y value, right? It's always going to be x and y, right? There's no shortcutting it. You can't do like y then x, right? You always have to follow that order. So for example, if we were to plot out letter A, to plot the point 3, 4, we first move 3 units to the right, the positive x-axis. And in order for us to get to where 4 is, we'd have to move 4 units up, right? So it's either if we're going to the positive x direction, we're moving to the right side. If we're going to the negative side, or rather negative x direction, we're going to the left side. And then up is going towards the positive y values, and moving down is going towards the negative y values. So if we were to plot out, let's say for example, letter B, In letter B, to plot the point -2, -3, we first start at our origin while moving first the x amount, -2. -2 means we move 2 units to the left, and -3 means we then move 3 units down. Same thing though in letter C. In this case, we have an ordered pair to plot 2, 0. This means that we're moving 2 units to the right, but since we have 0 here, we don't move up and we don't move down. We just stay right there, which gives us our ordered pair. That's where it should be. So super simple. Small brief introduction to the coordinate plane. We'll now get into start talking about how do we graph, right? What's like standard form, what's point slope form, and I think I'll try to go back and refer to a lot of the questions that will be on the tests, right? Of course, as much as I want to probably teach you guys everything that I can, it might be best to just focus on what we, how the questions will be answered, what are we looking for, what do we actually have to do, and then later on with your teachers like in Algebra 1 or even geometry, they can go ahead and help you more, I guess, like understand more like what kind of concepts are we working with. For example, as you saw on the previous slide, we might start working on using the scatter plot. Scatter plots are mainly just used to showcase real life scenarios and situations, right? For example, if we were to maybe like kind of guess weather reports, it's not only just like, oh, look up at the sky, right, and see if it's raining or if it's sunny or if it's cloudy, right? Sometimes we have to kind of think about, right, temperature and wind speed, and also like the time of the year, right? And so in order for scientists to take the data and kind of analyze it, they more than likely use some sort of scatter plot to kind of find trends within nature to then, have those accurate predictions. Because if you, quickly Google what's the forecast for tomorrow, usually they don't give you a for sure answer. It's usually like, oh, 70% chance of rain, which doesn't mean that like, oh, it's like, let's say for example 7 out of 10 times like the whole entire part of Guam will rain. No, it's more so you personally have a 70% chance to see rain, right? That means if I were to be here up in the north and I don't see rain, it doesn't mean that the prediction was wrong, because let's say for example my brother who lives down in Santa Rita, he might experience rain, right? Because he might win that 70% chance, right? So those are some things to consider when thinking about the uses of math and its applications in real life scenarios and situations. Anyways, we'll go ahead and skip all this stuff. Definitely you can go ahead and look at some of these questions and practice them on your own. But I will probably have an assignment for you guys to maybe try out. Since this is graphing, it is taking quite a bit of time for me to make one, mainly because I can't see you graph it for the most part, but maybe we'll just do like a simple worksheet style, and then we'll have that sent out to you guys. Anyways, graphing linear equations, right? An equation we all know is some sort of thing that has like x plus 3 is equal to 5, right? But when we're talking about a linear equation, we're always talking about something that forms a line. In order for us to form a line, we also need some sort of y variable to get put into this equation, right? So like what it mentions here, a solution of an equation into variables x and y is an ordered pair, x comma y. That makes the equation true. The graph of an equation in x and y is a set of all points x comma y that are solutions of the equation, and definitely in this lesson you will see that the graph of a linear equation is a line. For example, here, this lesson in particular will be a little bit more shorter, but we'll just go ahead and show you and justify the reasoning as to why we're using two different variables. For example, we have this line here. We have this line, x plus 3y is equal to 6. And any point within this line can be, and rather will be, the solution to this equation, right? You'll get the same number on both sides of the equal sign. And so our task is now to plot basically one of these points and see if they are solutions or if they're not, right? So in this case, let's start off with letter A. Letter A, we have 1, 2. In this case, we have to move 1 unit to the right and 2 units up. And if we move 2 units up, we can see that our point 1, 2 is not a solution to this line, x plus 3y is equal to 6, mainly because this point does not fall within the line. The question also asks us to justify our answer algebraically, so we'll go ahead and do that real quick. And how do we justify our answer algebraically? All we're going to do is just take this same equation, x plus 3y is equal to 6, and we'll go ahead and plug in 1, 2 in it when x is equal to 1 and y is equal to 2. We'll go ahead and plug these two values into what we have up here. Doing so, we get something like 1 plus 3 times 2. And if we were to solve this, 1 times nothing is just 1 by itself. 3 times 2 gives us 6, and we know for a fact that 1 plus 6 does not give you 6, and instead gives you 7, which means that 1, 2 is definitely not going to be our solution, right? So we can go ahead and cross that out. But let's go ahead and really quickly just check negative 3, 3. If we were to plot out negative 3, 3, we'd have to move 3 units to the back, or rather to the left, and finally 3 units up. 1, 2, 3. And we can see that this point definitely falls within the line, and we'll go ahead and also check this answer algebraically. We'll first go ahead and rewrite the equation, right? We have x plus 3 times y is equal to 6. We will then go ahead and plug in negative 3, 3, or basically x is equal to negative 3 and y is equal to positive 3. Then we'll go ahead and get something that looks like negative 3 plus 3 times 3. We'll first solve this out. We then have negative 3 plus 9 is equal to 6. And we know for a fact that negative 3 plus 9 is like saying 9 minus 3. And 9 minus 3 gives us a nice number 6, which means that we get the same number on both sides of the equal sign. Which then means that B is our only answer that falls within our equation. So this was a nice introduction to showcasing that within this line that we have for our whatever equation that we do have, there are many different points that will give us a solution, right? We just have to try to find them. But kind of using this as a nice segue to move into our next section, think about it in this way. What happens if you only have a point, right? A point, and where to go, right? If you're going up, or you're going to the right, or you're going up again and then to the right. What if you only had that, right? How can we make the line ourselves, and how can we determine if whatever line we're looking at is indeed the answer to our equation, right? Like what you may have seen in our previous pre-tests for the placement test, there was a section within the test at the very end, the last page, maybe like question number 23. It asked us which graphs corresponds to the equation, right? But how can you check that, right? There's different tricks and ways to prove that and to check it yourself. And we'll go ahead and cover that, I think, within this next section. So this is another brief introduction as to just showing you guys that there's different points within this line, and anything that's within the line is definitely a solution to the equation, while all the other points that are not part of the line will not be a solution to our equation. So different ways to plot this out. Don't worry, you can learn this maybe with your future teachers, but in this case we're trying to make this a little bit quick. And so first things first, our main topic, and rather main thing that we want to go ahead and do before we start using, let's say, a point, is trying to find out where do we go, right? Like, how do we find what direction the equation is telling us to go, and in order for us to find that direction, right, that I guess method of us trying to find where this line should it go like this, or should it go like that, or should it go like this, right? Who knows? we first need to use that use the equation and find something called a slope. In general, the slope of an equation gives us the direction to go. We will always have some sort of starting point to work with, while the slope will then tell us where to go. Should we go left? Okay, if we're going left, do we go up or down, right? Let's say we're going up, and that means if we're going the opposite direction, we should mirror this as well, right? So that's basically what the slope will do, right? And so in this next section, we'll go ahead and now look at how can we find the slope of a line, right? We'll work with that first, and then we'll showcase some examples of how you could use that to your own advantage. And then we'll try to maybe look at some problems that are similar to what we had in the placement test. So, finding the slope of a line. The slope m of a non-vertical line is the number of units the line rises or falls for each unit of horizontal change from left to right. A nice example of this is how we have it right here, right? We are moving left or right first, right? In this case, we are moving, or rather running, a certain amount of units, in this case going to be just 2 units, while we are rising 3 units, right? So moving 2 units to the right and rising 3 units up. So a lot of the times that we are looking at slope, we usually call this something, right? Slope has a lot of different names, right? Slope could also be called m. M is another way we can say slope. But one other way we can also say this is something we call rise over run, right? Rise over run just tells us how many units we are moving up, right? We're rising up or falling down. And then for run, we are either running to the left or running to the right. So how do we find our rise and our run given like 2 points, right? We would use something called it's failing me. This is basically the formula for us to find slope. M, or slope, is equal to rise over run. So how we find rise and how we find run is basically us just trying to find the change in the y values and the change in the x values, right? So these 2 points, we usually have the lower point denoted as x sub 1 and comma y sub 1, while the higher point we have x sub 2 and y sub 2. So we take these 2 points, right? We take the y sub 2 point and the y coordinate in point 2. Let's just denote this as P2, and this is P1. We take the y value from P2 and we subtract it with the y value from P1. Same thing with the change in x. We take the x value in P2 and we subtract it with the x value in P1. This gives us some sort of change in the x direction and also giving us some sort of change in the y direction. Now, it's very important that we keep it this way, right? Whatever you denote as 0.1, you have to make sure that this always will be denoted as x sub 1 and y sub 1, and you don't switch them around. This is because if you were to, let's say, for example, solve this slope as, let's say, for example, y sub 1 minus y sub 2 over x sub 2 minus x sub 1, a lot of times you will get an incorrect slope. So at least make it consistent, right? If you're using y sub 1 here at the start and you kind of mix it up, then make sure at the bottom you reverse these, right? But usually how we write it out is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Right, there you go. Subtraction order is different, right? Try to make it consistent. If you're using y sub 1 first, that's perfectly fine, honestly. You'll have to do some more simplifying in that case, but usually it's followed as y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So in this case, if we were to try to find the slope of a line passing through our point 1, which is -2, let's say P1 and this is P2, -2 comma 2 and 3 comma 4, what should we do, right? We would have to first take, and remember what our formula is, in this case it's just m. This will be denoted as the change in y all over the change in x. So from here, we have to now look at these 2 points that we have. point 1, which holds x sub 1 and y sub 1, and point 2, which holds x sub 2 and y sub 2. So from here, we know that for change of y, right, we'd have to now take the y values, y sub 2, and subtract it with y sub 1. And same thing in change in x, we'd have to take the x sub 2 value and subtract it with the x sub 1 value. This will now give us something like, if we replace them, right, with their appropriate values, we have 4 minus 2 all over 3 minus negative 2. And solving this, we end up with something that looks like 4 minus 2. This gives us 2. And we also have 3 minus negative 2, which starts to become 3 plus 2, which then becomes 5, which means our slope for whatever this is going to be 2 comma 5, which means at some point you will have to move 2 units up, and you have to also move 5 units to the right, right? That's how we kind of read it, rise over run. But with just this, right, how do we use our slope now to help us plot and rather graph some sort of equation, right, on a coordinate plane, right? How can we tell the difference between two lines and which line fits the equation that's written on the board, right? So using this, right, don't worry about any of this. Using this, let me find a blank page. Don't have a blank page. Using this, we can now start talking about slope-intercept form. Slope-intercept form is slope and intercept, but what is that intercept portion, right? The intercept portion will always be something we denote as b, right? In this case, when we're talking about slope-intercept form, we're referring to the formula that looks like y is equal to mx plus b. M, we already know that should be something called slope for us, while b, on the other hand, is something we call the y-intercept. Now, how long have we been? How long have we been recording? 22 minutes? Sorry about that. Anyways, let's just try to finish this real quick. Then we'll start talking about some problems. The y-intercept. The y-intercept is basically whenever our line crosses through some sort of point. That point specifically is going to be the y-axis. So in this case, if we were to look at this graph here, and if I were to ask you, what is the y-intercept of this graph here? We want to just look at the point at which our green line, or our line of our equation, passes our y-axis, right? So whenever the line passes the y-axis, we call this the y-intercept. So this point, if we were to count, right, from starting from 0, 1, 2, 3, this means that our y-intercept in this case, let's just denote this as, let me just erase this real quick. This is something we call the y-intercept, or you can abbreviate this as y-int, is going to be equal to 3, right? Like what it says right here. Likewise, though, if the line crosses the x-axis, this is also called the what? Okay, gave you guys like 5 seconds to answer that. Yes, it should be called the x-intercept, right? But in this case, we don't really use the x-intercept for much right now, especially in relation to the slope-intercept form. There is a form, like a type of equation that uses both the y-intercept and the x-intercept. This is something we call like finding zeros, and that's us just trying to basically create a quick graph. In this case, since the placement test doesn't really ask for that, we won't focus on that too much, but like I said, in your future classes, you'll definitely explore many different ways to express what kind of equations that we're trying to graph, and what they're used for, right? Their different capabilities. So in this case, if I were to ask you to find the slope and the y-intercept of the graph of the equation, how would you do that, right? we are just going to be looking at first, um, let's say, for example, 13. 13 as well as 14, they both fit the formula y is equal to mx plus b. We have mentioned already that m should equal to some sort of slope, while b should equal to some sort of y-intercept. And so if I were to show you this and plainly just ask you, okay, how do I find what's the slope and the y-intercept of these two equations, right? It's very easy to identify both those two things in both of the equations, right? We always just want to try to find whatever this m is in the equation. In this case, if we're looking at number 13, we know that our m is always going to be right next to our x value, right? So in this case, our m should be something, right? A nice number that starts with a s in the middle. It starts with an I, and then at the very end, it's an X, right? So 6. Sorry about that. That was painful for me to say too. And finally, anything that's at the very, very end, anything that's not attached with X should always be our y-intercept. So in this case, for number 13, it should be number 4. Likewise, if we were to have number 14 here, if I were to ask you, okay, what's the slope in the y-intercept? I'm pretty sure a lot of you guys will already identify them. In this case, our slope should be 3, while our y-intercept should just be 1. So using these two bits of information, right, our slope and our y-intercept, we can basically graph this, right, these two equations on a coordinate plane. And I'll show that right here. So if we were to graph this, right, very, very quickly, we notice for the most part that this equation is not in y-intercept form, right? Y is equal to mx plus b. So now how do we get this? This equation that's also known as standard form. How do we get this equation from standard form to look something like this, right? Is the question. Standard form, also the general way to write this is ax plus by is equal to c. And it's very, very easy to get any kind of standard form equation to get into slope-intercept form, right? And I'll show you guys real quick. So we have 3x plus y is equal to 2. Our main goal is just to get y alone. So how do we do that? We have to move 3x to the other side of the equal sign. We do this by doing inverse operations. 3x is positive and it's being added with y. Let's go ahead and subtract it on both sides of the equal sign, giving us something that looks like 3x minus 3x becomes 0. We're left with y here. 2 minus 3x, we can't combine. So let's go ahead and write them out like what we have here for slope-intercept form. Negative 3x plus 2, and this should be our newly written slope-intercept form. Now, if I were to graph this using my slope and my y-intercept, I have to first identify those two things. My slope in this case is going to be whatever is next to x. In this case is going to be negative 3. And my y-intercept, or my b, is going to be a positive 2. So a couple things. We talked about how slope is also written as rise over run. So how would I interpret negative 3 as a fraction like rise over run? It's very simple. If you were to have any kind of integer that's not a fraction, we just make it a fraction by dividing it by 1, right? Making it go over 1. So in this case, instead of writing it as negative 3, we'd instead write it as negative 3 divided by a positive 1, which now resembles something that's a little bit more familiar to us, rise over run. So using these two bits of information, our slope being m, which is negative 3 or negative 3 over 1, and our y-intercept, that is a positive 2, let's go ahead and now graph something that looks like this, right? So we have discussed these two things. Slope gives us direction. Y-intercept is where the line should cross the y-axis. So if I were to make a nice, really quick coordinate plane, Let's say it looks something like this. 1, 2, 3. 1, 2, 3, 4, 5, 6. And let's just label everything, right? 1, 2, 3, -1, -2, -3, -2, -3, 1, 2, 3, 4, 5, 6. We first want to use our y-intercept as our starting point. Right. We want to use this as our starting point. So what should we do? We should find where 2, positive 2 is along the y-axis, right? So wherever 2 is, this will be our new starting point. Now we'll go ahead and now use our slope to give us some sort of direction. Where should we go, left or right? How would the line look like? In this case, if we're just starting from here and using rise over run, this means that we are rising, or rather falling 3 units down. So let's start out with that first. So falling down 3 units, 1, 2, 3. And then running maybe to the right 1 unit. This is where our first point should be. You can keep following this method, going down then right, but what I also like to do is showcase how does that look like on the other side of the x-axis, right? Because if we keep going to the right, we'll only see whatever this looks like, but we won't get to see what's happening here on the other side. So let's reverse this. In this case, our slope tells us to fall 3 units down and move 1 unit to the right, but let's reverse that. Instead of us moving 3 units down, let's move 3 units up. So 1, 2, 3. From there, we'll then move 1 unit not to the right, but instead to the left. So even if my graph looks a little bit scuffed, it now gives us some sort of general idea as to how the graph should look like, right? We're converting first whatever equation we have from from standard form into slope-intercept form, and then from there we then want to find 2 main things. We want to find out what the slope is of the equation, and then finally what the y-intercept is for the equation. The y-intercept serves as our starting point for when we want to graph this, and our slope gives us some sort of direction. Where should the graph look like, and rather how should the graph look like when it's in the positive x direction, and how should the graph look like when it's in the negative x direction, right? So some fun stuff like that. There's one last thing. Let me just close this real quick. There's one last thing that I want to go ahead and talk about that I'm only just remembering right now, and that is when we're looking at the pre-tests, right? The placement tests. We covered a question that looks like this, converting to slope-intercept form, but what happens if we have something that looks like this? So these 2 questions, right? We'll go ahead and actually answer in one of these slides, and it'll be very, very quick. And I'll go ahead and showcase to you guys how we can solve these 2 questions, right? So in 24 it tells us to convert to slope-intercept form, right? Slope-intercept form, we said already, looks something like y is equal to mx plus b. And so how do we do that? We want to make sure that y becomes alone, right? So in this case, we want to rewrite this, right? And then focus on getting our y alone. So first things first, I told you guys earlier that we move our 4x to the other side, 4x minus it on both sides. We can't combine this, so we're just left with 2y is equal to negative 4x plus 14. We then want to maybe go ahead and divide 2 on both sides of the equal sign because we want to make sure y is alone. Doing so, we end up with something like y is equal to negative 4 divided by 2 gives you negative 2x, and 14 divided by 2 gives you 7. A nice equation now written in slope-intercept form. But how do we write an equation, right, for the line of these 2 given points? So, what should we do? There is something that we didn't have the opportunity to talk about, which is something called point-slope form. Now, what is point-slope form? How does it look like? Point-slope form looks something like y minus y sub 1 is equal to m times x minus x sub 1, right? So if we have these 2 points, 0, comma 3, and 2, comma negative 3, we want to first denote one of them as our first point and the other as our second point. And we know that in point 1, we only have x sub 1 and y sub 2. Y sub 1, whoops. Let me just erase this. Sorry about that. Y sub 1 values, and in point 2, we only have x sub 2 and y sub 2 values. So, first things first, we want to find our slope, which we have covered already, and then plug in point 1, right, whatever this is, into our equation here to find out an equation for the line that passes through those given points. So, how do we do that? First things first, we want to find rise over run. Rise over run is denoted as a change in y divided by the change in x, or y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now, all we have to do from here, once we figured that out, is just replace them with their actual values. Y sub 2 is given to us as negative 3 minus 3 divided by x sub 2 is 2 minus 0. Negative 3 minus 3 gives you negative 6 divided by 2 gives you negative 3. So now we have our slope. I'm going to go ahead and write my slope up here so it doesn't get lost. And then I will go ahead and erase all of this stuff real quick just to give myself some more space. So we found our slope. Our slope is written here at the top right, m is equal to negative 3. And now all we need to do is just take this m, plug it into our point slope form here, as well as whatever our point 1 is, which in this case is 0, comma 3, plug that into here as well. We now get something that looks like y minus y sub 1 is 3 is equal to negative 3 divided by x minus x sub 1 should be 0. And then we'll go ahead and simplify. First things first is we want to probably do distributive property, which means that we have to multiply negative 3 with the terms inside our parentheses. Negative 3 times x gives me something that looks like negative 3x. Negative 3 times 0 is just nothing, so this is what we're left with. Our last and final step now is then to add 3 to get y alone to both sides of the equal sign. And doing so, we end up with something that looks like y is equal to negative 3x plus 3 as our equation. But is this it, right? Is this the only thing we'd have to do? Not quite. We can definitely stop here, but we want to also make sure that this works for both points, point 1 as well as for point 2. So what we'll go ahead and do is now take this equation and just to double, triple check, plug both point 1 and point 2 into it separately and see if we get the same number on both sides of the equal sign, right? So let me rewrite our equation up here. Y is equal to negative 3x plus 3. Let me go ahead and erase all of this stuff here at the bottom. I'll go ahead and just show you that this equation should work for both points, point 1 as well as for point 2. So let's do just that. In this case, our equation, y is equal to negative 3x plus 3. We'll go ahead and replace the x values into where x is and the y value into where y is. We now get something that looks like 3 is equal to negative 3 times 0 plus 3. Negative 3 times 0 gives us 0, cancels out, so we're just left with 3 is equal to 3, which means it works for us. But now we have to check point 2. This point 1 will always work, no matter what kind of, question it is, because that's the one you use, right? So the more important one is point 2, right? This is make or break. If this doesn't work, then you did it wrong, but if it does work, then you are absolutely correct. So let's go ahead and now take the same equation, y is equal to negative 3x plus 3. We'll go ahead and replace the x values with x, and then same old, right? So our y value is -3. Our x value is a +2. -3 times 2 gives us something that looks like -6. And -6 plus 3 gives us -3 on both sides of the equal sign. So because of this, we can now say for a fact that this equation, y is equal to -3 plus 3, is indeed the equation for the line through the given points, right? This, if you were to graph it, you'll definitely see these points within the line of this graph, and that should be pretty much squared away. Okay, 40-minute video. Honestly, I think I'm just gonna leave it like this. And I think it might be better for us to meet and talk about anything else you might have more questions on. If you want to give me more examples, or rather, if you want me to give you more examples, please let me know. But as for now, I've made the video long enough. 40 minutes of me just yapping. We'll go ahead and stop it here. And yeah, I'll see you guys in our next meeting time. Please stay safe. Enjoy your summer. Most important thing, I want to stress this one more time. This is something that is up to you if you want to do. No stress. Don't worry about it. There's no deadlines. Just enjoy your time off school. And then if you have really nothing to do and this is something that you find yourself wanting to brush up on, then the content's all here for you. I'm available to ask questions anytime, so let me know. I'll try to get back to you as soon as possible. Anyways, I'll see you guys next meeting. Please stay safe, and I'll see you then.